All right, so example one, we're supposed to perform a 75-degree rotation of triangle XYZ about point P. So a rotation is going to have a center of rotation, which in this case point P is my center of rotation. P could be anywhere. The angle, the triangle, the points can be anywhere. Whatever you're trying to rotate, you're going to rotate all the vertices. If there's a single point you rotate, you just rotate the one point. If you got a line segment, rotate the 2 points in the line segment and then connect the dots. In this case, we have 3 vertices in this triangle. I'll rotate all 3 and draw the new vertices. One thing I need you to know is about rotation as far as signs are concerned. Angles can be positive or negative. A positive angle goes counterclockwise. A negative angle goes clockwise. So when you're looking at this, it says perform a 75-degree rotation. That's a positive 75 degrees. That's a positive angle, so we're going to be rotating counterclockwise. So if a clock goes this way, right? Yep. So counterclockwise is the opposite way. So if I'm rotating counterclockwise, this is here, it's going to be shifting this direction. It's very important that we go the right direction, counterclockwise or clockwise, based on the angle given to us, either positive or negative. All right. So basically, I'm looking at this picture. I'm envisioning this triangle is going to move around here somewhere. It's going to end up down in this general area, 75 degrees. I know what a 90-degree angle looks like, right? So if I have a 90-degree angle, you know, kind of like, let's see, 90 would be about here. So 75 would be a little less than that. So maybe somewhere in here. I don't know. But my protractor is going to give me my angle measures for me. Okay, I don't have to really focus on that. I'm just going to use my protractor to do this. And the way we do this by hand is like so. We take our protractor first, or straight edge, doesn't matter. In fact, I'm going to go with straight edge. Okay, I'm going to take my straight edge, I'm going to line it up with the letter I'm going to be rotating. I like to rotate them in alphabetical order, it doesn't matter. You guys want to start with Y, you sure can. I'm going to start with X, then Y, then Z, that's what I do. So, I'm going to do 2 things here. First thing I'm going to do is get it right on X, right on P, and I'm going to connect those with a dotted line. Notice I'm on the centimeter side. I did that on purpose. Okay. The other thing I want to see is I want to see the distance from X to P. Can everybody see based on my ruler up on the board? It looks like 3.5 centimeters.
Yeah.
All right. So I'm going to say PX equals 3.5 centimeters. So I want PX prime to also equal 3.5 centimeters. When you rotate, you're rotating circularly. So whatever radius you're creating here, which is PX in this case, as you rotate, the distance from your rotated point needs to be the same distance from your center at all times. All right? I don't have to draw a circle, though. I need to find the exact 75-degree measure. And since I'm going counterclockwise, I want the 75-degree angle to be on this side of my line. So I take my protractor then, P is my vertex. I place my protractor like I'm supposed to with the circle open on P, and my line right here is lined up with my dotted line, and I find a 75-degree angle, which I don't know if you guys can see very well or not. It's right here on my paper. Let me zoom out a little bit, maybe you can see it. Zoomed in. I'll zoom out again. My little blue point right there. So again, my protractor's on P, it's lined up along the line. Right here, here's 70, here's 80, so 75 is in between those two. So I marked it right there. Be careful I didn't come all the way over here because that's beyond 90 degrees. So I'm starting at 0, 10, 20, 30, 40, 50, 60, 70, 80. These are my 2 numbers. I need to be between those halfway. So be careful when you're measuring the angle. And what I'm going to do is that is the direction from P through this point is the direction I want to go, but I need to go exactly 3.5 centimeters to get where point X prime is. So I'm going to take my ruler now, place it on P at 0. I'm going to have my ruler lined up along this other dot here, which I know makes a 75-degree angle with my line. And I'm going to put a dot right here at 3.5. And we're going to call that x prime. So that's how you reflect a point. We have exactly 3 points in this to do, so we're going to do the same thing with all 3 points. So my second point, I'll do this in a different color, we'll go red. I'm going to repeat the process here. So I want to draw a straight line, I want to measure how far is it from P to Y. My ruler looks like 3 centimeters. And I want to draw a straight dotted line from Y to P, like so. So I know that PY is equal to 3 centimeters, which means that PY prime also has to be 3 centimeters. Okay. Once I construct the line and determine the length, I take my protractor, place the open circle on P, line it up with my red dotted line this time, get everything lined up nice and pretty, and I'm going to put a dot at 75 degrees on that also. And again, I'm going to be as precise as possible here when I place my point. I'm dead on that 75, close as I possibly can to make that extra point. It shows up very well on the screen there. It's right there, this red dot. Doesn't look very red on the screen, but pretend it's red. All right. So that's the direction from this red line through that point, a 75-degree angle. So I'm going to draw a point, Y prime, exactly 3 centimeters along that line. So I put my 0 down on P. I put my ruler lined up with the other dot. And I come down here to 3 centimeters and I put a dot right there. We're going to call that Y prime. I've only got 2 color pens up here, so I'm going to go to the next one's going to be blue again. All right. So my final point is Z that I need to rotate. So again, I'm going to line up my ruler, put it on Z and P. I want to find out length, and I want to make a dashed line. So according to mine, I'm looking straight down. Looks like 2.7 centimeters. So I know that PZ is 2.7 centimeters, which means that PZ prime has to be 2.7 centimeters. I'm going to draw a dashed line from P to Z, being very precise as I do it, holding down my tool very solidly as I come like that to make that dashed line. I'm going to place my protractor on P, line it up with the blue dashed line I just made. And I'm going to mark a 75-degree angle again, all the way to 70. There's 80, 75 is in between, so right about here is where 75 is. I take my straight edge ruler, and I want to measure exactly 2.7 centimeters from P towards this point here that marks 75 degrees. Oops. Pretend that line's not drawn. Just need the dot. There's my Z prime. Put an X because I made a stray mark there by accident. So I just needed the dot and made a line by accident. Not thinking. Okay, so all 3 of my points, X prime, Y prime, and Z prime, have been identified. Then I simply connect the dots to make the triangle. Make sure you connect them in the same alphabetical order, X to Y, Y to Z, Z to X. For a triangle, it doesn't really matter. You're going to get a triangle, but when you get bigger figures, more points, then you got to make sure you go the right directions. And there we go. I'm going to erase this. It's not in the way. And again, we took this and we rotated it 75 degrees that way. Yes, Kennedy?
Mine doesn't look like that.
It is mine.
Okay, and it boils down to precision. Again, it's
Mine's just like
be as precise as you can.
They probably put their thingy flat and they didn't line it up.
I don't understand how you know which centimeter
I got you. Okay.
They probably
So
didn't-
real quick,
Right next to it.
I think it might be going to the wrong 75. So
No,
if I
mine's just like
everybody take a quick look here. I'm gonna do the red one again here, right?
Do this, are you making this into?
All right. So if I'm at P and I'm lined up here, right?
You don't like
So how do we know which 75 to go to?
I
So
go like this, and then I go to this 75.
my line's going this way,
Just
right?
measure it.
So I'm looking at this as my 0. So if I'm going to be growing in size as I come this direction, 10, 20, 30, 40, 50, 60, 70, 80. So we take 75 is right there. If my line was going this way, right here, if I was coming over here, then I'm looking on the outside numbers. So whichever direction your line's going, that represents where 0 degrees is, and then you're growing from that as you come down the way. So, and again, that's the most common
Are
reason
you
people
gonna
have
check
the
our
wrong angle.
homework?
I'll measure everything.
That's gonna take forever.
Yeah, well, all right. And then real quick, one other thing, and you don't have to do this, but I mean, since I have these drawing tools, I'm going to show you real quick. If I were to have a circle centered at P, if I grow that circle out, notice that X and X are on the same, X and X prime are the same radius. Notice that Y and Y prime are the same radius. Notice Z and Z prime are the same radius. So that's, because again, we measured from P, so P is the center of the circle. The radius should be equal in that sense. And again, we didn't draw the actual angles, but we actually measured the angle to get the point, to get where the new point belongs. So that's how we make it happen. Again, it comes down to precision, comes down to measuring the angles correctly, and again, go to the right 75 degrees. So again, if 0 is this direction, if P is here and the protractor is coming this direction, that's where 0 is. You're going up from 0 as you count. That'll get you the right angle when you do it.
Is this what?